We are going to solve some problems on microwave engineering. And to start with, question 1 says, define S matrix and its properties. Scattering matrix is a square matrix which gives all the combination of incident and reflected power waves. Relationship between the various input and output ports of a microwave junction. The elements of scattering matrix are called scattering coefficients or scattering parameters. All these scattering matrix coefficients are smaller than 1. That is, it is represented Sij is less than 1. The properties of scattering matrix. Number 1, it has square matrix property. It is always a square property in n by n format. Number 2, unitary property. That is, the product of a matrix and its complex conjugate is equal to unitary matrix, that is equal to 1. If you have the matrix and its conjugate is equal to 1. Number 3, it has symmetry property. A matrix is symmetric if the Sij is equal to Sji, that is, the input to output and the output to output ports does not change the transmission properties, being a passive component. Number 4, under perfect matched conditions, the diagonal element of S matrix are 0. Number 5, it has complex conjugate property. The sum of product of a term of any column or row multiplied by the complex conjugate of any other column or row is always 0. Number 6, all these scattering matrix coefficients are always less than 1. Okay, question 2. It says, in an arrangement for measuring impedance of a reflectometer, what is the reflection coefficient when the outputs of the two couplers are 2 milliwatt and 0.5 milliwatt respectively? Okay, given that we have the incident power and we have the reflected power as given in the question, 2 milliwatts for the incident power, 0.5 milliwatt for the reflected power. Now, getting the reflection coefficient, we have the reflection coefficient rho is equal to the square root of reflected power all over the incident power, which is calculated to be 0.5. That means the reflection coefficient of this network is 0.5. Question 3. Two identical 30 dB directional couplers are used to sample incident and reflected power in a waveguide. The value of VSWR is 6 and the output of the coupler sampling incident power is 5 milliwatts. What is the value of the reflected power? In this type of question, we recognize that VSWR is given to be 1 plus rho all over 1 minus rho, where rho is the reflection coefficient, and here In the question, the VSWR is given to be 6. So by substituting this into the equation, we have 1 plus rho equals to 6 into bracket open 1 minus rho bracket close. So if we solve the equation, we have 7 rho equals to 5. That means rho is equal to 5 all over 7, which is equivalent to 0.174. In this aspect, to get the value of the reflected power now, we have the formula for the reflection coefficient, which is the square root of reflected power all over the incident power. So making reflected power the subject of the formula, we have P subscript R, which is the reflected power, is equal to rho square times the incident power. And as the rho, which is the reflection coefficient, has been calculated to be 0.174, so here we have rho square, which is 0.714 square times 5, which is the incident power, given to be 5 milliwatts. That means if we do the calculation, we have 2.55. Therefore, the reflected power in this waveguide is 2.55 milliwatts. Question 4. What is transit time? The B part says, write the classification of microwave tubes. And the C part says, what do you mean by O-type tubes? And name some O-type tubes. Solution to question A, which says, the time taken by an electron to travel from the cathode to the anode plate of an electron tube is known as transit time. While the B part, which asks us to classify microwave tubes, they are classified into 2 types, that is O-type microwave tube or linear beam, and the second one is the M-type microwave tube. It is also called cross beam. Okay, the C aspect, which in O-type tube, a magnetic field whose axis coincides with that of the electron beam is used to hold the beam together as it travels the length of the tube. It is also called as linear beam tube. Now, the O-type tubes are, number 1, helix traveling wave tube. Number 2, coupled cavity TWT, that is traveling wave tube, coupled cavity traveling wave tube. Number 3, forward wave amplifier. Number 4, backward wave amplifier. And 5, backward wave oscillator. Question 5. The A part says a coaxial RF cable with a characteristics impedance of 50 ohm and capacitance of 40 picofarad per meter. Now calculate the inductance. And the B aspect says a coaxial line has L inductance of 50 nanohenry per meter and capacitance of 50 picofarad per meter. Now calculate the characteristics impedance. The C part says when 2 identical couplers are used in a waveguide to sample the incident power as 2 milliwatts and reflected power as 0.25 milliwatts, then find the value of the VSWR, that is the voltage standing wave Solution to question A. To calculate the inductance. Already we know that the characteristics impedance, which is Z0, is equal to the square root of L over C, that is the inductance over the capacitance, in a coaxial RF cable. So, given that the characteristic impedance of this coaxial cable is 50 ohm, and the capacitance is given to be 40 picofarad per meter. So by substituting into this formula, we have 50 is equal to the square root of L over 40 times 10 raised to power minus 12, which gives L to be 0.1 times 10 raised to power minus 6 Henry per meter. Invariably, we can say the inductance is 0.1 microhenry per meter. So the B part says the characteristics impedance. In order to calculate the characteristic impedance of this coupler, which has the incident, which has the inductance of 50 nanohenry per meter and the capacitance of 50 picofarad per meter. So already we know that the characteristic impedance is calculated to be square root of L over C. So if we substitute the value of L, which is 500 times 10 raised to power minus 9, all over the capacitance of 50 times 10 raised to power minus 12. So the characteristic impedance gives us 100 ohm. So for solution to question C now, it says we should determine the reflection coefficient when two identical couplers are used in a waveguide to sample the incident power as 2 milliwatt and reflected power as 0.25 milliwatt. Then find the value of the VSWR. To find the VSWR, we must first of all get the reflection coefficient, which gives the reflected power all over the square root of reflected power over the incident power. And if we substitute the value of the reflected power and the incident power, we have reflection coefficient to be 0.288. Now we can now calculate the VSWR, which gives 1 plus rho all over 1 minus rho. And we have our rho to be 0.288. That means 1 plus 0.288 all over 1 minus 0.288, which gives us 1.80. Therefore, the value of the VSWR is 1.80. Question 6. The A part says state the reciprocity theorem, and the B part gives us a calculation of a coaxial line has L equals to 50 nanohenry per meter and C, which is the capacitance of 50 picofarad per meter. Calculate the characteristics impedance. The B part has been solved in the previous question, but the solution to question A now states that the theorem states, that is the reciprocity theorem, states that when some amount of electromotive force or voltage is applied at a point in branch K with a value of volume, with a value of voltage in respect of K in a passive linear network, This will produce the current at any other point in another branch of a branch M with current in respect to M. Now, the same amount of current in branch K is also produced when the same electromotive force or the voltage is applied in the new location of branch M with respect to the voltage in M branch. That is, it can be represented with a formula of, let's say, V subscript K all over I subscript M is equal to V subscript M all over I subscript K. Now, the B aspect, which has been solved before, already we know that the characteristics impedance is calculated to the square root of L over C, and by substituting the value, we have the characteristics impedance to be 100 ohm. Question 7. Define lossless network. And the B part says, if S11 is equal to 0.2, S22 is 0.2, S12 is 0.5, and S21 is 0.5. Now find whether the network is lossy, symmetric, or reciprocal. Also find the insertion loss. Now, the A part of the question says, define lossless network. In any lossless network, in any lossless passive network, it contains no resistive element. Always the power entering the circuit will be equal to the power leaving the network, which leads to the conservation of power. Now, a network is lossless if no real power is lost. It can also be said that the sum of the square for the first row element of S matrix is equal to 1. That means the sum of Sij square is equal to 1, where I equals to 1 and j equals to 1 to n. From 1 to n, j is equal to a value from 1 to n. Now the B part, if we want to, number 1, to know whether a network is lossy or lossless, we should be able to prove that the square of the coefficients of the first row of the matrix, as the sum of the square, should be able to give us 1. That means the sum of Sij square must be equal to 1. Now let us try. For this, we are given that S11 in the first row is 0.2 and S12 is 0.5. They are both in the same first row. So we have 0.2 square plus 0.5 square, which amounts to 0.29. Automatically, it's not equal to 1. That means the network is lossy. In the second aspect, we want to know whether the network is symmetric or not. As we have S from the properties of matrix, scattering matrix, a network is symmetric, is reciprocal, if Sij is equal to Sji, that is, the input and the output interchange should be able to give you the same value. That means there won't be any difference. So here we have S12 equals to S21 with a value of 0.5. S12 is 0.5, S21 is 0.5. That means the network is reciprocal. In the third aspect, we want to know if the network is symmetrical or not. For a network to be symmetrical, that means for this network to be symmetrical, S12 must be equal to S21 and S11 must be equal to S22. So let us check. S12 is given to be 0.5, S21 is given to be 0.5, S11 is 0.2, and S22 is given to be 0.2. Automatically it is symmetrical. Now the C aspect says we should calculate the insertion loss. Now the formula for calculating the insertion loss is minus 20 log one of the transmission coefficients. We want to know when a transmission line is introduced into this network from the source and the load, whether it will give a loss or a gain. So in this aspect, we were able to calculate the loss by having minus 20 log S21. S21, a value of S21 is the same thing as S12. That is the voltage transmission parameter, which is given to be 0.5. So minus 20 log 0.5 into base 10 dB gives us minus 6 dB. So the network has an insertion loss of minus 6 dB. Question 8. What is the zero property of S matrix? And the B part says write the unitary property for a lossless junction. And the C part says define non-reciprocal devices. Solution to A. It states that for a passive lossless n-port network, the sum of the product of each term of any row or any column multiplied by the complex conjugate of the corresponding terms of any other row or column is 0. Example, if we have the sum of Sij and the conjugate of Ik is 0, where j is not equal to k. This is a column case when we are considering a column aspect. If we want to consider the row, that means the sum of Sik with the conjugate of Sjk must be equal to 0. So where I is not equal to j. In the B part, for any lossless network, the sum of the product of each term of any row or of any column of the S matrix multiplied by its complex conjugate is unity. That is, the matrix S and its conjugate must be equal to 1. That is a unitary matrix. And the C part says define non-reciprocal devices. A non-reciprocal device does not have same electrical characteristics in all directions. Examples of these microwave devices are circulators, isolators, and gyrators. Question 9. Write about the skin effect in a wire. And the B part says if a line having characteristics impedance of 300 watt is open circuited at far end, what is the VSWR? Question A, which says we should write about the skin effect in a wire. In a wire, as frequency increases, the electrical signal propagates less and less in the inside of the conductor. Now, this current density increases near the outside perimeter of the wire and causes higher impedance for the signal to propagate further, and this will act as the resistance of the wire. So in this aspect, we have R, which is the resistance of the wire, is directly proportional to the length of the conductor and inversely proportional to the cross-sectional area of the conductor, where we have the rho to be the resistivity of the conductor. And A is the cross-sectional area, and L is the length of the conductor. So the B part, so if a line is open-circuited, we have the reflection coefficient to be 1, and the VSWR can be calculated to be 1 plus rho with respect